Answer your attendance. Afla,
Present, Miss.
Ajmina, Ajmina, Amaya,
Present, Miss.
Atulya,
Present, Miss.
Drishya,
Present, Miss.
Jyotish,
Present, Miss.
Karthik,
Present, Miss.
Kavya,
Present, Miss.
Nachiket,
Present, Miss.
Neeraj,
Present, Miss.
Rangeet,
Present, Miss.
Vaishnav, Anjali, Shruti. Okay, good morning, all of you.
Good morning.
Good morning, Miss.
Yeah, how are you all?
Fine.
Fine, Miss.
Okay, your assignment as well as the unit test has been corrected and the marks has been uploaded. Register number 1 to 4, you have to make me a call before 3:30 or after 7 today. Okay, register number 1 to 4, and tomorrow then 5 to 8. Like each day you have to 4 people can make a call. Okay, so I want to tell your corrections, etc., and all, like how you have to improve your way of writing, etc. Okay, we'll start. Now, what we have seen in the last class. Kavya. Okay, Afla, you can answer. What we have seen in the last class?
Character-oriented protocol and
Error, error control protocols. Okay, you were dealing with the second layer of the internet model or the OSI model, that is called it as the data link layer. Now, the specific functions of data link layer includes data link control as well as the medium access control. Now, data link control has got some sub functions. You have framing, you have flow control, and the other one function is called it as the error control. Now, last class you have seen what is framing and also flow control. Framing, you can have two types. One is fixed size and the other one is variable size. And also flow control, you have got the two categories of flow control mechanism. One is called it as the stop and wait protocol, and the other one is the sliding window protocol. And after that, you have gone with the error control protocols. Error control protocols, what is the importance of that is error detection as well as correction takes place in that type of protocol. Atulya, you want to tell something? Atulya, you can mute your mic if nothing is there. Okay, so in that you have seen what is stop and wait ARQ, right? Now, error control, the importance of error control protocol is that here a retransmission of data is done. That means whenever a frame is damaged or lost, then the receiver is allowed to inform the sender about the retransmission of data. And that is done by a process called ARQ. ARQ means automatic repeat request. So with the help of that, then the receiver can inform the sender to retransmit the damaged or the lost frame. Okay, and you have seen what is the working principle of stop and wait ARQ. Stop and wait ARQ, the main important things are sequence numbers are present in each frame, and also the acknowledgement are also numbered. And the sender will be keeping the copy of each frame what it is being sent. Okay, so if they want to do the retransmission, so in order to do that, they should keep a copy of each frame, whatever they are sending. Okay, so if the frame is damaged or lost, the receiver will send a non-acknowledgement and the timer will expire. Based on that, the retransmission process takes place. Now, today we will be seeing about the second type of error control protocol, that is called it as the sliding window protocol, sliding window ARQ. Sliding window ARQ, you can have two different categories of that. One is called it as the go back N protocol. Other one is called the selective repeat or selective reject protocol. Very, very important, all these protocols. The one is go back N protocol. Other one is selective repeat protocol. Now, what is the working principle of this go back N protocol? So, as I told in the earlier class, what is the difference between stop and wait and sliding window? Stop and wait, you are sending only one frame at a time. You are waiting for an acknowledgement after that, then only the next frame is sent from the sender side. But what happens in the sliding window protocol? You can transmit multiple frames. That is the difference between two protocols. One is stop and wait, the other one is sliding window. So sliding window, what is multiple frames are sent or they are in transition. Now what is the importance of this protocol is it improves the efficiency of transmission. Efficiency in the sense the transmission medium, you are making use of a good use of the transmission medium by sending multiple frames. In stop and wait, it was not like that. You are sending only one frame at a time. It was not used, the medium was not used effectively. So in sliding window, you are making a good use of the transmission media. So the efficiency of transmission is improved in sliding window when you are compared with the stop and wait protocol. Okay, now in this go back N ARQ, you can send up to W frames or capital N frames before waiting for an acknowledgement. That is the thing, meaning multiple frames can be sent. So, and whatever frames you are sending, you will be keeping a copy of that until the acknowledgement arrives from the receiver side. So what I told is in go back N, you can send maximum of N frames before waiting for an acknowledgement. And also you will be keeping a copy of the frames until the acknowledgement arrives. Okay, now you have got similar to that what you have studied in flow control. Here also you will be keeping sequence numbers to each frame. Now, if actually that sequence number will be added in the header. In each frame, you will have an header field and the sequence number will be added along with the header field. Now, you need a limit for that. How many numbers you have to put in a window or in what is the sequence number you have to put it. Actually, if the header of the frame, if it allows m bits for the sequence number, then the sequence number ranges varying from 0 to 2 power m minus 1. The range of the sequence numbers that you can put is, it is varying from 0 to 2 power m minus 1. As an example, if m is equal to 3, the number of bits you are making use of, if it is 3 bits, then the sequence is ranging from 0 to 7. 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7, and the same sequence is repeating again. Okay, so in go back N protocol, sequence numbers are put in that range can vary from 0 to 2 power m minus 1. Okay, and that sequence number is put it in the header of each frame. Okay, now As I told, this is an example of sliding window protocol. Now, what is the importance of sliding window in go back N? So sliding window, as we know, it defines the range of sequence numbers. Here I told 0 to 7. That means each window, the window size is 7 now. It can accept frames, or at a time it can include the frames from 0 to 7. So the sliding window, it defines the range of sequence numbers, and that is the concern for both sender as well as the receiver. So when you are considering the sender slider window, as you can see it in the next slide. So the window size, what you have kept it is 7. Now, the range which is the concern of the sender, that is called it as the sender sliding window. Here in the diagram, you can see the sender sliding window. Before sliding, what happens, and after sliding, what happens. So before sliding, the 7 frames are occupied in that window, and that range is the concern for the sender window. Okay, and whichever range is the concern for the receiver, that is called it as the receive sliding window. Okay, now what happens to the sliding window? Now, when it has a change, whenever you are receiving an acknowledgement, the window slides. The principle, as the last class I have just told, how the window is getting slided. When a data goes out of the frame, as well as whenever an acknowledgement receives, then the window is getting slided towards the right. Okay, understanding? You have go back N protocol, go back N maximum number of frames. It is the sequence number can range from 0 to 2 power m minus 1. Assume m is equal to 3 bits, then the window size is varying from 0 to 6, or the window size is equal to 7. Okay, now you have the center sliding window as well as the receiver sliding window. The importance of sliding window means it defines the range of sequence numbers. Now, the window slides. Now, how does the window slides is whenever you are getting an acknowledgement, the window is slides towards right, and whenever his data is gone out of the window is getting slided. Okay, so that is the concept of this sliding window. Now, what about the receiver window? So this is about the sender sliding window. You can see once after sliding 2 frames, what happens to the window? See, you can see in the diagram, once you are sliding 2 frames, the wall of this window is shifted towards right by 2 units. That is what it is written after sliding 2 frames. Okay, so 2 new frames are included. Once it has been slided, 2 new frames will be included. Now, what about the receiver sliding window? Now, in go back N sliding or go back N protocol, the sliding window, the size of the window of the receiver is 1. Earlier case in flow control, when I'm explaining, they had both the same size, the center window as well as the receiver window. But when you are considering the go back N ARQ, the size of the window of the receiver in this protocol is always 1. Okay, now it is actually whenever a data comes or a frame comes from the center side, it will check whether the frame is in the specific order or is in the correct order. If the frame is out of order, you have got 2 windows, that is before sliding and after sliding. So before sliding, it was kept it at 0. Now after sliding, it is shifted towards 1. Okay, so there is the window size is 1, only 1 frame only it gets shifted in go back N protocol. Okay, so 2 things I have told in go back N ARQ. One is the sender sliding window, the other one is the receiver sliding window. Okay, now what about the control variables in this go back N protocol? Now, whenever you are considering a frame, I have told you have got 2 types of window. One is the center window, the other one is the receiver window. Now look on to the sender window, what you can see it in the diagram. So here the sender has got 3 variables. One is S, the other one is SF, the other one is called SL. Okay, now S is nothing but it is the S variable holds the sequence number of the recently sent frame. Whichever frame is sent recently, S value holds that sequence number. Now SF is nothing but it is the sequence number of the first frame in the window. Here in that window, you can see 0, 1, 2 are in the window and 0 represents the first frame in the window. So SF is pointed towards that. Okay, so SF holds the sequence number of the first frame in the window. Now SL, it holds the sequence number of the last frame in the window. Now the size of the window, you can calculate it as SL minus SF plus 1. SL minus SF plus 1. This is in the case of sender window. So I have told you have got 3 different control variables in a sender window of go back N protocol. So you have got S, you have got SF, and the other one you have got SL. S is nothing but the recently sent frames sequence number is denoted it as S. And SF is nothing but the first frame and SL is the last frame in the window. Okay, now coming to the receiver window, it has got only one variable and that variable is denoted it as R now. Okay, now actually that frame it denotes it is expecting that frame to receive. So whatever number is highlighted in the receiver window, the meaning is that it holds the sequence number of the frame it expects to receive. So I have sent an acknowledgement and then I am expecting what frame. So that number is denoted in the receiver window. Okay, so if the sequence number of the received frame is the same as that of the value of R, then the frames will be accepted. If it is not, then it will be rejected. So whichever frame sequence number is inside the receiver window, if that same frame is coming from the sender side, the frame will be accepted, otherwise it will be rejected. Understanding go back in protocol, I have told 3 things now. One is about the sender sliding window, how does it work in go back in ARQ. The other one is the receiver slider window. The window size is only 1 in case of go back in ARQ. And what are the control variables in both the center window as well as the receiver window. Okay, now similar to that in the flow control, what you have seen here also you have got timers. Now the timer is present only at the center side. The receiver does not involve a timer circuit. Okay, so now if the frame is not reached within a specified time, you will be starting the timer, and once the timeout value is reached, then it will be resending the frame. So in order to do that, the center is equipped with a timer. Now, what about the acknowledgement process? So the acknowledgement process is the receiver sends positive acknowledgement if a frame has arrived safe and in order. If the frame is arriving safe and in an order manner, then the frame is accepted and also the acknowledgement is released from the receiver side. Now, what happens if the frame is damaged or if it is received out of order? 2 possibilities are there. What happens when a frame is damaged or if it is receiving out of order? Now, what the receiver does is the receiver is silent in that case. The receiver is silent. The meaning is it will discard all the subsequent frames, whatever it receives, the one which it is. So suppose if it is expecting frame 0 And if data 1, 2, 3 are coming from the sender side, now what it will do is it will discard all the frames. Until and unless the 0th frame is receiving, it will accept that. Understanding? So it is called it as go back in. So when a frame is damaged or it is getting out of order, whichever frame is expected at the receiver side, the receiver will accept only that frame. Now, if some other frames are reaching the sender side, it will discard all the frames and it asks for the retransmission of the entire frame. So that is the working principle of go back n protocol. Go back n means you have to go back to the n frames, whatever it is being transmitted, if the frame is lost or damaged. Okay, so I'll just show with a diagram for that. Now, this is the normal operation for a go back in ARQ. Now, all of you look into this diagram. I hope you can see the slide. Yes, Amaya? Shruti?
Yes.
Shruti is there? Shruti, you can see the slide? I can't hear anything. Anjali is there? No, okay. Vaishnav? He is also not there. Vaishnav? Okay, then Ajmina? Ajmina? Yes? Ajmina?
കാണുന്നുണ്ട് മിസ്സേ.
I can't hear what you are telling. Okay. Understanding the concept of go back and ARQ. Okay. Now, what is the normal operation of go back and protocol? Now you can see you have a sender as well as a receiver. Now the size of the sender window, you can see 3 frames are occupied in that window, 0, 1 and 2. Okay, now what happens when frame 0 is sent from the sender side? Now the receiver is expecting 0, right? So it will accept that frame, and at the same time, frame 1 is also sent from the sender side. So sliding window, I have told multiple frames can be sent. Okay, so from the sender side, 0 and 1 frame are sent. The receiver window, it is expecting 0, it has received, it is expecting 1, okay, it has received that also. Now, what it will do is, it will send a cumulative acknowledgement, ACK2. ACK2 means it is expecting data frame 2 now. So once the sender receives the acknowledgement, it transmits the next frame. So it is not compulsory that every time the receiver should send the acknowledgement. Whenever it feels like sending, like a cumulative acknowledgement, it will be sending. But here in this diagram, you can see after the first 2 frames, the receiver sends the acknowledgement. Now from once frame 2 reaches the receiver, then acknowledgement 3 is sent. Now frame 3 is transmitted. Okay, so this is just the normal operation of go back in ARQ. Now what happens when a frame is lost? What happens when a frame is damaged? So you can see in the diagram when a frame is lost. So you can see frame 0 and 1 are sent, acknowledgement 2 is received, but the sender has transmitted frame 2. Okay, but it is the receiver. You can see the receiver is expecting frame 2 in its window, but the frame 2 is lost. Now what happens at that time? The timer starts. The timer starts and it will wait up to the timeout value, and until and unless, so what all frames it is receiving in that timeout value, all the frames are discarded. Frame 3 has reached, so it will be discarded. It is not in the window, so the frame 3 is discarded. Okay, now once the resend of frame 2 happens, then it will accept that and then retransmit the acknowledgement. So this is happening in go back N. So that is that name, go back N, means when a frame is damaged or lost, the receiver will be expecting some frame. Now, if the sequence number is same as that of the frame that is sent from the sender side, it will accept that. Otherwise, what all frames they are receiving from the sender side, all the frames will be discarded. So the sender has to retransmit the frame whichever is lost, whichever is fresh. Now it is transmitting again the same frames, 2, 3, again it is being transmitted. Okay, so that is the working principle of go back N. All the frames until and unless the correct frame is received, all other frames are getting discarded. Okay, so this is about the lost frame. Now what about if it is lost, the acknowledgement is lost. Acknowledgement is lost. You can see just in the diagram, 0, 1, 2 reaches the receiver. It sends an AZK2. So AZK2 is lost there. Now what happens? The timeout value, the sender will wait up to the timeout value, and whatever data is sent after that, so it is expecting 0 after that, acknowledgement 2. Means the 2 data has been reached properly and it is expecting data 0, the next data. So it is seen on the right hand side, the data 3 is discarded. Now it is expecting 0 and 1, so the data frames are recent in that case. Okay, so go back in ARQ, you just understand that the frames, when a frame is damaged, the sender goes back and sends the set of frames starting from the damaged one up to the last one it is sent. So it is going back and then transmitting. So it is called it as the go back N protocol. Okay, now, so this is the 3 cases of this go back N ARQ. One is the normal operation, the lost acknowledgement or the lost data frame, or the lost acknowledgement frame. Okay, understood? So I repeat once again, sliding window ARQ, what does it mean is the multiple frames are sent in transition. One type of protocol is called it as the go back in ARQ. Go back in ARQ, you have some control variables both in the sender window as well as in the receiver window, and you also have sequence number, and the size of the window, it depends upon the varying from 0 to 2 power n minus 1 of the sender window. Now similarly for the receiver window, the size of the receiver window in go back in is 1. Okay, now if a frame is lost or damaged, now whatever be the protocol, they will keep a copy of the frame what they are sent from the sender side for the retransmission purpose. Now when a frame is lost or damaged, then it will the timer starts in one manner, and once the timeout is reached, the correct frame is accepted at the receiver. And if it receives the frame other than the window, what frame is specified in that window, if it is receiving the other frames, then all will be discarded and it will go back again. The sender will be transmitting the data again. So it is called it as go back N ARQ. Okay. Now, the next type of protocol is called it as the selective repeat. Now you have got in your textbook, you have got the design of go back N ARQ. Here, this you can go through it, what it has been explained, and the algorithm also that I'm not taking in the class. Just you can just read it, and the same working principle is explained as an algorithm. Okay. Now, the third type of protocol is called it as the selective repeat ARQ. Selective repeat ARQ. Now, what does this mean? So, go back in ARQ if you are comparing, the receiver tracks only one variable, right? In go back in protocol, the receiver keep tracks of only one variable. And there is no need of any buffer to out of frames. What it does is they will simply discard the frames. Okay, now that type of protocol, that is the go back in protocol, it is very inefficient in a noisy link. Now what happens if it is and you have a noisy environment? So the go back in protocol is inefficient in a noisy environment. So in a noisy link, now what happens is you have the higher probability of frames getting damaged. In a noisy link, you have the higher probability of the frames being damaged. Okay, that means a resending of multiple frames takes place in a noisy environment or in a noisy link. Okay, now that resending, it makes use of the bandwidth and the transmission is getting slower now. Okay, so for noisy link, there is another mechanism is being designed that does not want to resend the end frames. The meaning is whatever frame is damaged, only that frame needs to retransmit it. So it is called as selective repeat. Understanding the meaning? Selective repeat means whichever frame is damaged, only that frame is, need to transmit it again. Not all the other frames what the sender has already sent to the receiver side. Okay, so that is the case of selective repeat. I'm telling once again, for a noisy environment, go back in protocol is inefficient. So noisy environment, you have the higher probability of the frames getting damaged. So retransmission must occur in a frequent manner. So you are making use of another type of protocol that is called as the selective repeat ARQ. Selective repeat ARQ means only the damaged frame should be sent, not all the frames. Only the damaged frames should be sent. Now, what about the sender window as well as the receiver window in case of selective repeat protocol? So sender window, it remains same as that of the go backend. You have three control variables as you can see in the diagram. You have S, you have SF, and you have SL. But what about the receiver window? So the receiver window is looking for a range of sequence number. It has got two control variables here. One is RF and the other one is RL. RF and RL, it denotes the boundaries of the window. Okay, so you have got two variables in the receiver window. One is called RF and the other one is called RL. But the center window, you have got S, SF, and SL. Now, what happens when a frame is damaged or lost or an acknowledgement is lost in case of selective repeat? So you can just see in the diagram. So from device A to device B, you are sending 0, 1, and 2 as being sent. Now you have got an error in that frame, data 2. So what the receiver will do? It will send an NAK frame. NAK2, it denotes that is expecting data 2 again. Okay, so by the meantime, data 3, 4, and 5 is reached the receiver. Okay, so the data 3, 4, 5 is accepted in case of selective repeat. They are kept it in the buffer in selective repeat. But what was happening in go back in 3, 4, 5, if it is reaching, it is simply discarding, it discards the data. But selective repeat, the other frames, whatever frames they are getting from the sender side, they are kept at the receiver buffer. And once data 2 is reached the receiver again, they will rearrange that frames and then they will involve in the transmission process. Understanding what is the difference between go back N and selective repeat. So you can see data 2 is in damaged position. So damaged case. So what sender will do is NAK2 is sent as per the diagram. So the data 2 is resent again from the sender side. But in the meantime, it has received data 3, 4, and 5. In go backend, they were simply discarded. Okay, but in selective repeat, they are not discarded. They will be kept in a buffer. And once data 2 reaches the receiver safely, they will rearrange the things and involved in the transmission process. Okay, so this is the case of damaged frame. Similarly, it is the same case of the lost acknowledgement or the lost frame. The working principle, it remains the same. So it is a duty of the receiver to reorder the frames, okay, and send it to the topmost layer. Okay, so I hope you understood the difference between selective repeat and go back in protocol. Yes or no? Should I repeat it again or? So I am telling once again, error control protocol, 2 types you have got. One is go back in ARQ, the other one is selective repeat ARQ. So only this you understand, go back in ARQ once the frame is damaged or lost, until and unless that frame is reaching the receiver in a perfect order, all other frames are discarded. But selective repeat, the other frames are accepted and they will send an NAK frame. Only the particular frame is retransmitted from the sender side. Okay, so that is the meaning. Go back in, and the other one is selective repeat. They are selecting it and then repeating the transmission. Okay, so these are the things that are present in the error control protocol. Understood? Shruti is there? Shruti?
Miss.
Shruti, I can't hear you. Ajmer.
Yes, Miss, ഞാൻ പറയുന്നുണ്ട്.
Vaishna is there? No. Vaishnav? No. Anjali? Okay. Jyotish, you want to tell something? Okay, so go through the textbook today only. Tomorrow I'll be having 2 hours. So one for 10 minutes to 15 minutes, I'll be conducting a quiz. So the portions, last class also I told, one is based on the transmission media and the other one is based on the flow control mechanisms. Okay, so prepare for that. And who will be summarizing today's class? Karthik. Karthik? Yeah, summarize the class. I can't hear if you are telling.
Go back to sliding window and go back to selective reject to.
I am not able to hear you. Okay, maybe some problem, I don't know. Okay, so see, you were able to hear, no, what I have told? Because I can't hear you what you are telling. Yes, okay. So go through the textbook today itself and understand the concept. Okay, the slides I'll be sending it today itself. Thank you.